All right, Rocket City Podcast. Welcome. Today we have a special guest, a good friend of mine. We had a lot of adventures together, including one running away from bears. We won't talk about that story this time around. Having close calls with boats and jet skis.
Yeah. It's a fun weekend.
Yeah. Dustin.
What's up?
How you doing, buddy?
Hey, doing great. Happy New Year.
Happy New Year.
Yeah. Hope you had fun.
Yeah, it was good.
I got to watch a bunch of model rockets get launched up at midnight. It was awesome.
Indeed.
Yeah, it looked really cool.
Indeed. So, Dustin, where are you from?
I am.
And
sorry.
You're good.
Jump the gun there. Go for it.
It's all good, man. Where are you from? Where did you go to school? And tell us about your background, your degree, and what you're studying now.
Oh, man, so many questions fired at once. No, so I am from a little town called Port Charlotte, Florida. It's on the Gulf side, in between Punta Gorda and Sarasota. But
Okay.
I went up to Tampa, Florida, for college for University of South Florida. Got my physics degree. Yeah, that was back in 2013. I knew that I wanted to continue my education into a graduate level, but I didn't want to go straight into one. So I kind of jumped around from job to job to see what I could do with just a bachelor's in physics. When I was still getting it, I got a part-time job at Busch Gardens in Tampa.
Yes.
So I worked at a theme park. I worked for their education program. So I did a lot of their sleepover programs, their summer programs, things like that. Got a lot of really cool experience, teaching experience and animal experience, because it's essentially a zoo down there.
Yeah.
I mean that quite literally. So I got to take kids behind the scenes with all the different areas of the zoo, and I essentially learned what it was like to be a zookeeper at the same time. So that was really cool. We also did a lot of behind the scenes tours of roller coasters.
Wow.
So I got to actually meet with some of the engineers that helped build those coasters. And got to see them like when they were taking apart the train cars. They do it every 365 days that a train car is on the track. They have to bring it out and basically take the entire thing apart and replace every single part of it to make sure that it's, safe and ready to go.
That's very, that makes me feel safer about riding roller coasters.
Roller coasters are way safer than you think. You
Yeah.
always hear about these stories of roller coasters like getting stopped on the tracks and stuff,
Mm-hmm.
but that's actually a very safe thing for roller coasters to do. They have block brakes every part of the track. So if there's something that the computer system detects that's not right, that's not optimal, they will stop them on those block brakes just to make sure that nothing happens.
Wow.
And then people freak out and they're like, "Oh, this coaster stopped here. It's so unsafe." It's like, no, actually, that probably just saved your life.
Interesting.
They're really, really safe. It's really cool to have had the experience to be able to see like how they're built and all the safety mechanisms that goes with it. It was really cool.
That is cool. And we met in a specific place that just for professional purposes, and I won't necessarily name, but I think it's so interesting, all the people we meet and all the cool experiences they've had, and just all the value and the talent and skills. And I think we connected quite a bit because of all the experiences and different jobs we had.
Oh,
that was
for
your
sure.
main job, though.
Yeah.
And it was really cool that you had that experience behind your belt.
So I was part-time there for quite a few years. I never got full-time.
Really?
Yeah, I was there for about 7 years.
Even
yeah.
as a manager? I thought you were a manager at one point.
So I was not manager at Busch Gardens. I was manager at the Museum of Science and Industry.
Oh,
that was
right.
also in Tampa.
Okay.
So I had both of the jobs at the same time. So I was part-time at Busch Gardens and did all that really cool stuff. But then I was full-time manager of guest experience at the Museum of Science and Industry.
Okay.
So that was really cool. I was in charge of a team that did live science demonstrations.
Yeah.
And we called each other the steampunks because we were themed science, technology, engineering, art, and math. So just that extra art concept of it on top of STEM. And we would, just to be engaging with all the guests that came through, we would dress up as steampunk characters, so kind of like the cosplay characters.
Yeah, and you can actually find some of this online.
Yes, you can.
Which is great.
There's a few videos on YouTube of some of the shows out there. I even did a live science demonstration at the Association of Science Technology Centers conference that was in Tampa. That was in 2016. So feel free to look that up. It's ASTC 2016 live demo hour. Yeah. And I had 2 Tesla coils on each side of me, and I created a Faraday suit, which was basically chainmail, but it covered my entire body. And I had the electricity hit me from both sides, and it would just travel on the outside of my suit. And I would just do different things with it. It was really fun.
And when this man says he's a physics major and he loves science, it's an understatement because he's over here with Tesla coils and a Faraday suit.
I will admit there was a small gap in my left wrist between the glove, and when the Tesla coil came on, it hit me right in my wrist.
Yeah.
And if you look carefully in the video, when it first turns on, you can see my arm kind of coil back to it, and I kind of did an electric slide to the right to get out of it.
Yo, that's smooth electric slide.
And it was in the middle of the show live where people are watching me, so I just had to continue on with the show and act like nothing happened. Thankfully, after they turned off for that segment, I kind of adjusted it while I was still talking, and I didn't get electrocuted the rest of the show. So
that's impressive, man. You just let that roll.
Yes,
good.
It was. Hey, great story, right?
Great. So, what are you studying now in school? And,
yes. So I did end up going back to school. Like I said, I was going to before. Only took a couple years or so. I just wasn't getting what I wanted out of the job force with a bachelor's. So I am now a graduate student at Embry-Riddle, but it's through their online program, so I can still be right here in Huntsville and take all their classes. And it's for a master's in systems engineering.
Alrighty, systems engineering.
Yep.
And where does that concern itself in your New Year's resolution for 2018, which is impressive, and you always make me jealous when I'm looking at your Snapchat stories. I'm like, dang.
Yes.
So he's well, you explain it, but every time you see him, he's like, yeah, 363, 364, 365. Yes. I'm like, dang, every day.
Almost 365. But to explain, so my New Year's resolution of last year, of 2018, I had never been in a gym before. I never really worked out. I used to be a runner. So I would do cardio stuff all the time, but I never weightlifted. I just never worried about it. And then last year with Planet Fitness, I saw that it was only $10 a month. And I just thought to myself, I was like, man, I've been called skinny my entire life. So many people would be like, oh, eat a burger once in a while. And I'm just like, I do all the time. It doesn't work. So for 2018, I was just like, you know what? I'm gonna do it. I'm gonna get a gym membership, and I'm not gonna be like the majority of people who get a gym membership, go for like a month, and then get tired of it and leave. I wanted to make it the entire year being consistent. So my New Year's resolution was to go to the gym, and it's more specifically, I wanted to work out every single day, as many as I could the whole entire year without having any off days. Which a lot of people, when they hear about it, they're like, what? That's crazy. You need off days to rest.
Yeah.
I never did the same workout, back-to-back days. Right. So I would always do upper body one day and then lower body the next. That way, when I'm doing my lower body, my upper body would rest. And it worked out fantastically.
And so you have not had a single rest day for over 300 days now.
I wish. So that's the concept. Yeah, I know. So nothing is a perfect system.
Right.
I attempted it. My goal was, because I knew that I wasn't going to be perfect. It's almost impossible with life that happens when you travel and stuff like that. Sometimes you just can't seem to get a workout in with everything that's going on in your life. Right. So my goal when I said it was I want to have like a 90% consistency rating. So whatever out of 365, I don't know, like 335 or something like that out of 365 is what I was going for. So I started it 10 days into 2018.
Okay.
So I'm still technically
2018.
I started in 2018.
Oh, okay. Gotcha. Yeah.
Technically, so I'm still in it because I have 8 days to go.
Gotcha.
But I this morning before coming on this show, I was at day 366.
Wow.
No, not 366, 336. Sorry.
336?
336.
Okay.
So it's going to be, I'm projected to be in like the 341, 342,
Okay.
which is going to be more than 90%. So I could just not work out the rest of the 8 days and I'm already over 90%.
Yeah.
But I'm not going to do that. I'm going to keep to it.
Yeah. All right. Let me clear the math up right there because I'm a little confused. 2018, you started December 2018?
No, I started January 10th, 2018, 10 days into the year.
But that's 2 years ago.
20.
You
Wow.
kept saying
You're right.
2018. You're fine.
I've been
You're
saying
fine.
2018 this
I
whole
was
time.
like,
I'm really sorry.
No, yeah.
20. I forgot that it's 2020. Not
It's 2020
2019.
now.
I'm not used to it being 2020 yet. I apologize for this entire segment already.
You're fine.
2019 is when I started. It is 2020 now.
Boom. That's why I was like, whoa.
Yep.
Well, you should already finish if you started in December, like 10
sorry.
days prior. That's why I thought, you're
Yeah.
fine.
No. You were trying to correct me that whole time. And I was just like, no.
No. No, you're good. So, are you going to continue doing this? What is your plans for the next? And the result? Well, actually, let's just go over the results. Like, what do you feel better?
Oh.
100%. And like,
Oh yeah. So when I started, so just picture this. I'm 6'3". Before going to the gym, I weighed about 135 pounds.
wow.
6'3", 135. Very underweight. I've been underweight my whole life. Now, I actually measured myself this morning. I'm 178.
Oh, whoa.
Yes.
I mean, like me and your friend and all your other friends have like noticed the improvement. We're like, holy cow, man. Like he's really getting it. And we're like, wow.
It's like one of the best parts about it is when I go back home, I won't see my brothers or my family for like 6 months at a time. I'll go back home and they're just like, holy cow, Dustin, is that you? Like, you look so big. I was like, thank you. And that just like, it makes me feel really good. It makes me, it makes me know that, or it lets me know that it's paying off. It's actually working. So, to continue on, I'm not going to stress myself out and trying to do it every single day.
Yeah.
I'm still going to go to the gym often, but I'm not going to
You're going to take rest days.
I'm going to still keep it a habit to go like every day after I get off work. So I'll probably go like 5 days in a row. Yeah. I probably won't go on my days off that I have every week because, there were some times that I was like really stressed about it, especially if I was traveling or if I was like hanging out with someone throughout that day. And I'm like, oh man, I really got to get in my workout. And it's like, I'm going to have to sacrifice, hanging out with this person who I haven't seen in forever, or like, sacrifice something so that I can get that hour and a half to go to the gym to work out. So if I'm ever in that situation, I'm gonna be like, I don't have to worry about it. I'll just have this as a rest day and go tomorrow.
Yeah. And how long would you work out for? Or like, I know it changed, but like
on average, it was usually about 45 minutes to an hour long workouts. Okay. My runs would usually take a little bit longer.
Right.
But when it was weightlifting, it was usually about 45 minutes to an hour.
Okay.
Yeah.
Neat. And this is a good transition into what you want to talk about in working out in the human body in outer space, and how it's very difficult to just live and do everything you need to in outer space because it's a totally different environment and your body starts to change. And we literally we start to become like a different organism or species in its own way.
Well, I probably wouldn't go that far. Maybe
I feel like
maybe if we start reproducing in nothing in microgravity, and then we just never, from those kids, they never experience gravity, and then they reproduce, and then they never experience gravity. And probably a couple generations down the line, our DNA might change enough to where we're probably not Homo sapiens anymore. But
well, that's why I have you here. You to explain the details, and I just like the big picture guys. Like, whoa, my God, we're like on a rock floating around a ball of fire and stuff like that. But,
yeah, but isn't everyone?
Yeah.
But yes, so working out, it's astronauts on the ISS, when they're microgravity, they take about 2 hours every single day to work out.
Yeah.
Which is about twice as long as I did.
Yeah.
Down here on Earth. Now, with me being on Earth and experiencing one gravitational pull of gravity, my body is always feeling that pull, so it's always having to combat it. So it essentially is always working to keep it up. But if you're in microgravity, like the astronauts that, especially the ones that are there for 6 months or a year at a time, they don't have that constant pull of gravity, so their bodies essentially become lazy. It's kind of like if you picture yourself, you're like an Olympic runner, and you are training up, to be in the Olympics. You're getting stronger, faster, or if you're already really strong or fast, you're essentially maintaining your time, maybe like taking a second off here and there.
Right.
But then picture that runner to just stop running for an entire year, doesn't do a single run for that year. Their body's going to get lazy.
Yeah.
Their muscles aren't going to be as strong after that end of the year. It's kind of the same concept with astronauts in space. When you're in microgravity, even if you work out for 2 hours in the day, just that constant lack of that gravitational pull on your body, you're going to end up losing that strength.
Yeah.
Now, it's possible to be in microgravity and to keep up your strength, but it would take working out all day.
All day?
All day.
Oh, my gosh.
So, I mean, astronauts, they do it for 2 hours and every day. That already takes up a lot of their time of what they're up there to do. I mean, we're going to spend the millions and millions of dollars to send these guys up there to do all of these really important experiments. We can't just have all of their time go to working out. That's just kind of a waste of money at that point.
Yeah. I had the opportunity to escort Larry DeLucas, an astronaut in the shuttle program, and he was talking about he performed an experiment where he wasn't going to work out, and he was up there for in the shuttle for a week.
Okay.
And he lost 30% muscle mass.
Yeah, I believe it.
Didn't work out for a week.
I believe it.
So it's crazy.
Yeah. I mean, it's amazing what, gravity can make your body stronger.
Yeah.
That's why, the legend of Superman, why he can jump so high and almost be like he can fly is because the gravitational pull on his world is so much stronger than on Earth that he's just that much stronger than humans.
That makes so much sense.
It works in the opposite direction. If you live your entire life on the ISS or anywhere that's microgravity, you're going to be really weak.
Yeah. Wow.
But yeah, so the whole reason why I bring this up is because with my studies in systems engineering, I started last year. So I still have about a year to go before I get my degree. But I've already studied a lot of different systems that have been really interesting. So just to kind of explain exactly what systems engineering is, because I'll be honest, I didn't know what it was before.
I really don't understand
before
it
I select it. So systems engineering, it's the person that takes the big picture of an entire project. So for example, you have different disciplines of engineering. You have civil engineering, you have electrical engineering, you have mechanical engineering, you have all these different types of engineering. Systems engineering, it takes all of those disciplines and make sure that they come together to form one coherent system. So a great example of it would be the NASA Space Launch System, the SLS. What it does is, that's a system that it takes an input and it generates a desired output. So the input would be the entire SLS system. It inputs fuel and commands from humans, the pilots and the astronauts. And then it outputs, velocity change in order to transport a payload to a desired location off the Earth. Does that make sense?
Yeah, and I think a lot of people would assume the engineers from every department just puts all that together. But the fact that, no, there's like a separate thing because you need to make sure all of it works together correctly. And there's different things you have to worry about, I assume, from each discipline. If
you think about it, like let's just say you're an electrical engineer and you're making sure that all the wires are in the right place and they're doing the correct functions and the software is going through correctly. You are so focused on that that by the time everything that you're in charge of, like it works perfectly, then you're kind of like, okay, now what?
Yeah.
And it's like, there has to be someone overhead to make sure that your finished product connects with the rest of the system to make sure that everything works properly.
Yeah.
So when it comes to systems engineering, that's what it is. So the SLS is the system itself, but then it can always be broken down into subsystems.
Right.
So for the SLS example, some of the subsystems it would be like the components and things such as like the rocket boosters, the cryogenic propulsion stage, the Orion capsule. They're all required to interact with each other for the entire rocket to do what it's meant to do. Does that make sense?
Yeah. And so it's like you're the leader almost. You keep all the glue together in a way. Like,
yeah, it's more of a project manager.
Yeah, project manager.
It is a leadership role for sure.
Yeah.
They're the ones who oversees everything.
Which I would think you would do a fantastic job at. And
Thank
I
you.
can't wait
Thank
to
you.
see where you take all that.
That's one of the reasons why I chose systems engineering, is because I've always looked at the bigger picture.
Yeah.
One of the reasons why I got into physics as an undergrad is just because I wanted to learn how everything worked.
Yeah.
I didn't want to just be a certain discipline of engineering. I just wanted to know everything about everything.
Amazing.
So systems engineering is basically kind of just expanding that, but in a more technical sense, so that you are very useful for huge projects such as the SLS or maybe the heavy, the Falcon Heavy for SpaceX. What I'm really interested in is because all these examples that I've said, they're already made. They're already created.
Right.
What I'm really interested in is space stations, lunar gateways, Mars bases, lunar bases, things that people are wanting to make, but they haven't been made yet. That's what I want to get into specifically.
Yeah. Because that's really how we're going to be able to just live in outer space in the beginning. I mean, that's where we are right now. We're with the ISS and all the space stations where we put up. That's the main thing we're focused on really in space.
Yeah. So
currently.
When it comes to systems engineering, you break up the system into a system life cycle.
Okay.
And the systems, it's the job of the system engineer to come up with this life cycle, so that from the time that it is just a thought in the back of your mind or the back of a couple people's mind from brainstorming to the time that it is retired and disposed of, that is the entire system life cycle. And the systems engineer has his hand in all of it.
Wow.
So it starts with the operational need. So that's like, why does the system need to exist to begin with? What justifies it? You don't want to just put all of this money and time and effort into something that is not going to be useful.
Right.
So that's like the first step. The second step would be the system concept. So that's when you build a conceptual model to represent what it would be like when the finished product is done. That's when requirements are put into it. So for example, let's say NASA wants for the Lunar Gateway, a space station that orbits around the moon.
Mm-hmm.
One of the requirements is it needs to be able to refuel ships or spaceships that come through that are either going to Mars or somewhere else that's even further beyond. Well, that's a pretty big requirement, but it's not going to make sense for me to make a model that doesn't fulfill that requirement.
Right.
So it's like, with systems that are this big, there's hundreds of requirements, and you need to make sure that you hit on every single one. Because if you miss one, then it's like, okay, well, we want this system for a reason. We're going to put all this money into it and all this effort into it. It needs to fulfill everything that it needs to be. Right. Or that it needs to refill.
Okay.
So once that initial model gets passed and you present it to your stakeholders, to anybody who's willing to put money into it and they're happy with it, then it goes on to the next stage, which would be exploration and validation. And that's when it goes into the specifics, components, and things like that. So all of the subsystems that I talked about with the SLS, that's when all the models get broken down into subsystems and the components of the subsystems and all the technical performance measures and things like that. So what would be needed to make, trying to use an example here.
Anything, right?
Yeah, it's.
This is a heat tile from a shuttle, so why don't you use that?
Okay, perfect. So this heat tile right here, this is just one small component of the heat shield for the entire shuttle. Right. So a technical performance measure would be what to what temperature would this be able to defer? Like,
Right.
how hot can this get before it deteriorates and flakes off?
Right.
That would be a technical performance measure. So that's when qualities like that, get placed on the table to make sure that it is fulfilling its very, very specific requirements.
Right.
Yeah, go ahead.
What's specific requirements? We can jump back, kind of starting out. What do you think? I mean, we can go down the history of the space stations in general.
Oh, yeah,
But
yeah.
as far as Skylab,
Yeah.
we could use those examples and talk a little bit about this space station history in general. So Russia, we beat Russia to the moon. They're kind of I think peeved by that. So, but they figured out how to put up the first space station, and with the Salyut program, and they also weaponized some of those, and those were called the Almarez.
Okay.
And then they went with the Mir and stuff after that. But we sent up Skylab, and did you had some information on Skylab?
Yeah. Well, so the history of space stations is actually it's really interesting.
Yeah.
So the whole concept of a space station first came to be in about 1869. It was like 1869, 1870 in that time. It was all science fiction, of course, at this point. But it wasn't even called a space station. It was called the Brick Moon.
The Brick Moon.
The Brick Moon. That's right. It was by an author named Edward Everett Hale, and the Brick Moon that he wrote about, that he described, it was 200 feet in diameter, and it was a brick sphere essentially. And when he came up with this concept, he didn't have it. It wasn't originally planned to have people in it. It was just a sphere that kind of acted like a navigational aid for ships that wanted to go to the moon or to Mars or anything else. So it was just a navigational aid.
Wow.
But in the story of when he wrote it, the space, not the space station, because that's not what he called it, the Brick Moon got launched when people were still working on it, when people were inside it.
Oh.
And it got launched, and those people got trapped in it and got launched with it into orbit. And so the whole story is how they're able to survive on this brick sphere that's orbiting the Earth. And that is essentially the first time that like the concept of a space station ever emerged.
Isn't it so interesting, like with Jules Verne's book and going to the moon, that we have stuff like this back in the 1800s, and we're thinking about it already?
It is very
finally
interesting.
Starts like 50 to 100 years later. That's crazy.
Yes. So the actual term space station, it didn't come about until about 1920s.
Okay.
It was by a Romanian rocket pioneer, Herman Oberth.
Yes.
I'm sure you've heard of him. He envisioned a platform that was orbiting the Earth, that it was to be a starting point for missions that went beyond it. So kind of similar to like how Edward Everett Hale had his, but Herman Oberth actually had his envision of people living on it operating it while it's out there.
And he's Warner von Braun's mentor.
Yes,
Which is
he
pretty cool.
was.
Yes, he was.
Interesting.
Yeah. I met his great-grandson.
Warner von Braun's great-grandson?
Yeah.
That's cool.
No, not Warner von Braun's great-grandson. Herman Oberth's great-grandson.
Oh, that's cool too.
Yeah. Anyway.
Interesting. Okay.
That was weird.
Man, I wish I could say something like that. I don't know. Maybe I probably have met some really big, important guy, and I just never realized it at the time.
He didn't tell me until like later. I was like, oh, okay.
Yeah.
Whoa. I saw Oberth, and I was like, his last name's Oberth. I was like, huh.
Oh, interesting. I wonder if that's related. But yeah, so after Oberth came up with that concept, there was an American engineer a couple years later by the name of Robert Goddard. Have you heard of him? Yeah.
America.
Yep. He was the first guy to start experimenting with liquid propelled rockets over here in America. But while he was experimenting with that, there was an amateur rocket group over in Germany that was also experimenting with liquid fuel rockets. And there was one specific guy that was handpicked out of that amateur rocket group to work for the German army. Do you know who that is?
That's Warner von Braun.
Yes, it is. That is Warner von Braun. Yes. So he was just in an amateur rocket group. Like that's all they were.
I didn't know that's how.
Yeah.
Wow.
And I guess he was making a lot of good progress with liquid propelled rockets. So he was handpicked and kind of like forced to join the German army. Right. And this is right about when World War II was going on.
Yeah.
So yes, he was building rockets for World War II. For Germany during World War II. And he ended up constructing the V2 rocket.
Right. We kind of went down this rabbit hole. In
the
previous episode, but keep going.
But there's a reason why I'm talking about it.
Yeah. You have
So he developed the V2 rocket's first rocket to pass the Kármán line, 100 kilometers above the Earth. All that, you've already done this in previous episodes. But the reason why I bring this up is because Hohmann or Birth, when he came up with the space station idea, he wanted. Or he knew that it needed to take very powerful rockets to get it up into orbit. And he knew that the rockets that we had now weren't powerful enough. So when Wernher von Braun he was developing liquid propelled, one of his things that he was thinking of in the back of his mind is, I can develop these rockets to help get a space station in orbit.
Oh my gosh, all the way back in World War II with the V2 rockets.
Yes.
A lot. I know there's different versions of the V2 rocket he had on paper that some were even like second stage and stuff. And he got in trouble, I think even locked up in jail for a little bit, because they thought the Germans wanted him just to construct missiles and blow stuff up. When he started putting people in it, they were like, what are you doing? Like in his designs.
Yeah. So after World War II, von Braun, and I'm sure you mentioned this in your earlier episodes, he came over to America with his blueprints. He built the V2 rocket here just to show us that he can build such a great rocket. And then he became friends with Walt Disney, and he got a Disney TV show called Tomorrowland. Did you talk about this in
I
the
have
early
not
episodes?
talked about that yet.
So for those of you who have heard of Tomorrowland, Wernher von Braun had a couple episodes where he talked about space stations on Tomorrowland. And this was kind of the first time that he was really pushing that information for the public to know.
Yeah.
And his concepts were crazy, but they made sense. They were really cool. He's the one that came up with the concept of the space station would be kind of like a donut, like a toroid shape, and that it would spin to create artificial gravity so that people would have gravity and their bones wouldn't liquefy.
And they're looking at that design now for a potential one. There's a few companies that are like, we're going to try to build that, and they've designed on like computers and stuff, different ones, and they think they might actually start building one of these.
The concept is correct.
Yeah.
All the logic behind it is correct. It's just actually making it. Yeah. Actually building it to where it is safe for humans to be in, and getting it into orbit and keeping the orbital motion consistent. That's what's really difficult, and that's why we haven't done it yet. Yeah. So that's kind of where space stations, they got started. Yeah. It was just a science fiction thing that an author back in the 1800s created, and then all these people who were building rockets are like, you know what, we actually are starting to get the technology, this actually might be possible, and they're like, let's just try it. And I mean, that's how a lot of technology happens, right? They're just like, hey, let's just try it, see what happens. So with von Braun being over in America and working for NASA, and getting the concept out on Tomorrowland, the Disney TV series, all these people were getting really interested, and NASA decided to go ahead and start researching and trying to build space stations. So it was in the 1960s that NASA ended up making inflatable wheels in Langley, Virginia, and the Langley Research Lab. They made inflatable wheels to kind of test out what a space station would kind of consist of, or what it would look like. Obviously, since it was inflatable, it's not going to really work all that well. But it was just like what's that?
They deployed these in outer space?
No, this is all on Earth. Okay. But they were just testing out concepts, like building models and stuff like that. In 1969, so this is when the Apollo program is going on. So when NASA was first founded, and they were going through Mercury and Gemini, they wanted to focus on a space station more than the moon at first.
I didn't realize that.
And then when they started getting into the Apollo program, and they started to hear rumors that Russia was going to the moon, America's like, Yeah, we're not very far in the space station experiments in research, so we're just gonna put that off to the side on the back burner, and we're just gonna go into the Apollo program and focus on the moon. So space station technology and things like that kind of got put on the back burner for a little bit. In 1969, it was still around. It just wasn't as much of a push. So in 1969, NASA proposed a 100-man space station, and they called it Space Base.
Whoa!
Yeah, you might not have known that.
What?
It went through like they built models for it and stuff, but then it kind of fell through pretty early on because it was discovered that the cost of actually building it and getting it up into space was going to be too much, because all of the rockets that they would use to do it at this time were all expendable. They were one-time use rockets. Think of like the Saturn V, the Saturn I, the Gemini, not the
Atlas.
Thank you. Yeah, yes. So they're all expendable. So it would cost more money in just getting the pieces up to space than it would to build the dang thing.
So what was it going to look like? It was in 100 people. That's insane.
Yes. Yeah. I don't have a picture with me.
Oh, that's fine.
Maybe Dylan can pull it up over
Mission
there.
Control.
But as he's pulling that up, I'll just continue on. So like I said, it was going to cost way too much. They didn't have they knew that they needed reusable vehicles to be able to have, save the amount of money to, to get it up to cost. So that's actually what kind of led into the STS program, the shuttle program. That
would make sense. I
mean, they needed a reusable vehicle to be able to go back and forth into space, so that they didn't have to rebuild every single time.
Yeah. Wow.
So in 1973, they used parts left over from the last 3 canceled Apollo missions.
Right.
So Apollo 18, 19, and 20, they got canceled, they got scrapped, but they had all the parts for it. Yeah. Well, they took those leftover parts, and that's what they used to create Skylab.
Yeah.
Now, Skylab was, the first space station that America had put up. Oh, looks like he's bringing it up right now.
This is the 100-person space base.
Space base.
We will be pulling it up on our video. But it looks like a modular space station, but massive.
Yep. Remember, it's supposed to be for 100 men.
100 men.
Yep. So that, of course, it was just concept. Nothing actually got built or anything like that.
It looks just like it kind of looks like just the ISS and other modular space stations. But they were thinking about 100 people at once. Yeah, and the modules look probably
the
way
one
bigger.
over on the left. Yeah, that one
right
has.
There?
That one was the most popular concept of
it.
When they were going through all the different ones, that was the one that I think they wanted to try to build the most.
It's so long.
Yeah. Well, remember, it had to house 100 people. So
100 people.
So when Skylab went up, they just used leftover parts from Apollo, so they had the money to do it because they already had the parts for it pretty much. But it was never intended to be a long term. So it was only up there for 6 years, and it deorbited over Australia in 1979.
Right.
Yeah, Australia got some good artifacts. Not willingly.
Including space poop. Yeah. That's what some Australian teachers told me once, that Australia charged the United States a $400 littering fine. It's really like it was just a promotion by like a newspaper or something. It wasn't actually Australia charging the littering fine. But my Australian teachers were like, yes, because the poop landed and it just smelled for hours and it survived deorbit. I was like, come on, that's not why. America never paid it. Some DJ in the 80s paid it.
Yeah, I was going to say, wasn't there a DJ host in California that ended up raising awareness and got enough? Yeah. So, all right. So while Skylab is in order, so before it even fell back down to Earth, this is when NASA formed a partnership with Europe, with ESA, the European Space Agency.
Okay.
And they formed a partnership, and NASA was telling ESA, like, hey, we're in the middle of building a reusable space transportation system, a shuttle, so that we can build a space station effectively. However, it's still going to be really freaking expensive.
Yeah.
So they partnered with ESA to help split some of the costs, so that ESA would take some of the research and stuff, so that we could actually be able to do it.
Yeah.
And ESA was like, yeah, okay, that sounds like a good idea. So they were on board. And then in 1984 to about 1986, Japan heard about it, and so did Canada. And they were really interested, so they actually joined on board with the whole idea of creating a space station out there.
They all signed that treaty.
Yep, exactly. At the time, so they kind of got rid of the whole idea for that first space station.
It's crazy.
So now, at this point, with Japan, some of the European countries and Canada in it, their new concept, they called it was an unofficial name, but they called it the dual keel space station.
The dual keel?
So,
what is that inspired off of? What does that mean?
So it's because the design that they came up with, there's two keels essentially. So you know how the ISS, it's just like one long keel and then you got like the solar panels going off of it.
Yeah.
Well, this one, they designed it for two that went across. So instead of just that one, they had two of them. It was dual.
Yeah.
But then right after the Challenger incident, they required that the space station would have to have some type of escape mechanism for astronauts if any emergencies happened.
Right.
So since they needed to add on, you can see it right there.
That's a good picture of a keel.
Yep, right there.
Double keel.
So the dual keel.
Dual keel, sorry. Yeah, dual.
So since they needed to add on this new escape system, whatever it would be, because they didn't know exactly how they were going to do it, they just knew that they needed to add on this extra thing. It was gonna be really heavy, and they didn't want the space station to be that heavy because it just makes it way more difficult and to get things up to it and build it and stuff like that.
Yeah.
So that's when they decided to go from a dual keel to a single keel station.
Okay.
And that's essentially where ISS started. At the time when they came up with that concept, they called it Freedom, Space Station Freedom.
Space Station Freedom.
Yeah, it was actually President Reagan that called it.
Wow.
He named it Space Station Freedom. But
I didn't even realize there's like different names in the beginning of the ISS. Like that makes sense now when you think about it. Because like where'd they get ISS from?
Yeah. So think of it as in a systems engineering point of view.
Yeah.
This is all still the conceptual design phase. You're gonna come up with one, and then when you present it to your stakeholders, and they're gonna be like, this isn't gonna quite work. We need a reiteration. And then you go back and you reiterate it. Well, depending on how popular the first name was, you might want to change it so people don't think that it's still your first design. So your second design is a different name. So it went through so many different designs that it went through so many different names.
That's interesting.
Yeah. So like I said, President Reagan called it Freedom once the finalized concept was all voted on and agreed upon. But it wasn't until the 90s, so it was referred to as Freedom for like 6 years.
Oh man,
from 1984 to either 1990, 1991, somewhere around there. The space station, the International Space Station, wasn't called the International Space Station. People would refer to it as Space Station Freedom.
Wow, and the astronauts I escorted who worked on the shuttle program even before the Challenger accident never even told me that ever.
I mean,
they don't even consider it. I mean, there's a lot of things they probably
I was gonna say
don't even talk about. It's just now. This is what it is now.
There's so much stuff to talk about. There's not enough time in the day to get through everything.
Yeah.
So I feel like that's not a huge thing. It's just like, oh, did you know it used to be called Freedom? Okay, cool.
Yeah.
But it wasn't until the 90s, and as it was going through the concept phase, they kept adding more and more technology to the space station. The concept, of course, they haven't started building it yet. And in their models, it was kind of having the same problems that the dual keel space station was having, where it was just getting too heavy. At some point, they were like, "There's too much stuff on this. It's too heavy. We have to do something." So they ended up it went through another redesign phase.
Another one.
Yes, it went through a lot of redesign phases. So there was 3 different models that was made up, and the White House voted on which of the 3 ones they liked the best, which made the most sense. And the one that they voted on was called Space Station Alpha. So now it's Space Station Alpha, not Freedom.
Space Station Freedom to Space Station Alpha.
Yes.
Why would you? Man, that's worse. Why would you go to Alpha, man?
So I'm not sure.
Department.
I'm not sure what the other 2 concepts were, because I only heard about what was actually voted on. But I can only assume that they were like Beta and Charlie or something. I don't know. Beta and Zeta. I don't know.
Yeah.
But I mean, I don't think that was going to be the final name, but
Yeah.
they just named it that just to get it through the concept.
Where did Russia come in on all this? Because so Russia, their space station program was before Skylab and during Skylab, while it deorbited, and then they sent up the Mir. But during the Mir deorbited in 2001, but we were working with Russia during that whole time with the ISS, and they actually added a bunch of parts there, the Zarya module and stuff like that.
So
the Zvezda.
So they had was it not Zarya, it was Zvezda. Their first space station. It was called. I'm drawing a blank. Do you remember what it was called? They had 9 of them.
Yeah, Salyut 1.
Yes, that's right. Salyut.
The military was
like during they had Salyut 1 and 2. I think was before Skylab.
Okay.
They were doing all this. This was just all of them. They weren't collaborating with any other countries, and they weren't even sharing information with the United States.
Okay.
Because at this point, remember, Russia was not Russia. It was the USSR. It was the Soviet Union. So they weren't sharing any of their information with the United States.
Right.
So while they were building and testing out all of these space stations, the United States is just like, we know Russia's doing or we know the Soviets are doing something, but we don't know exactly what it is.
Yeah.
But yeah, the USSR, they ended up having 9 of them.
Yeah. Wow.
That they would send one out, and then they would do experiments for a couple months. They didn't have boosters to keep it in orbit.
Okay.
So after a few months, their astronauts would leave, and then they would just let it deorbit and burn up in the atmosphere. And then they'd send up number 2 and do the same thing. And then number 3, 4, 5, 6, all the way to 9. So apparently they had more money than the United States at the time, or I don't know. Maybe their workers wanted to, they just were so into it that they would be paid less. Yeah. I don't know when it comes to that, but they had no problem just spending all of this money to send something up for 3 months and then to just let it burn up in the atmosphere.
Yeah. I think after all their failures with the N1 rocket and just blowing that thing up, and now it costs a lot of money, I think they're just like, all right, let's just take a step back.
They focused a lot of their time on space stations, which was really cool. And then so you also talked about the Mir. Yes, they did have another type of space station called the Mir, which is MIR. Now that's pretty interesting because when our shuttle program was going on, this was in the 90s, I think, late 90s, maybe early. No, I think it's late 90s because early 2000s was when the ISS actually started getting inhabited. But in the late 90s, mid to late 90s, when after the USS fell in 91 and it just became Russia. The United States and Russia started talking to each other more with it. And Russia was actually kind of interested in getting, helping out with this space station that so many other countries are already a part of. Yeah. And they didn't want to be left out. So they came up, they worked with NASA, with the Americans, to come up with the Shuttle Mir program. And what they did there is the Mir space station that they already had, they wanted to see if they could successfully connect their technology, their way of building space stations with the American way, or I should say with the ISS way, because it's, America and ESA and Japan and all that. So the Shuttle Mir program was testing out to see if they could build a docking mechanism so that the American shuttle could successfully dock with the Russian technology, the Russian-built space station, to make sure that, it was sealed tight, that they could successfully dock and pull away, and that there would be no damage or anything like that. And it was actually a huge success.
Yeah, so the Mir was the very first module space station, and I think you explained that very well.
Yep.
Where they just, they connect different modules together. And the ISS is also a modular space station. Yeah. But all the solid space stations were just kind of single use. They probably had some other technical term. China also, they did that recently with their space stations. I think it was 3 or 4 of their space stations after they used it, they burned up in the atmosphere.
Yeah, I'm not as familiar with all the Chinese space stations. Yeah. They kind of remind me of the USSR. They are very secret with what they're doing. And I mean, we just know that they're up in orbit.
Yeah.
And then we can actually observe when they crash down.
Yeah.
Not necessarily crash down, but burn up in the atmosphere. So they've had one or two actually burn up in the atmosphere.
Yeah. I think that they've had like 3 at least.
Is it 3? Okay.
I think they'll think about launching their 4th one, or they already did. I'm not up to date on
Yeah.
it. But another thing about the Mir, it's interesting. A lot of times they need help up there where they didn't have enough time between one of their launches, like got messed up, and they needed the shuttle to pick up their astronauts. There was one mission where they brought back, instead of 7, what is max capacity out on the shuttle, they brought back 8 astronauts because they helped out.
I remember
Yeah,
that.
they transferred crews and brought back 8 astronauts. Yeah. The Mir also, there's some interesting things that go on about it. It really, the Russians, kind of like an Armageddon, the movie, where that I think that is supposed to be the Mir in that movie. I don't know for sure.
No, they were on space shuttles and they went to an asteroid.
Yeah. No. They fueled up with the space station in the very beginning, and I think it's supposed to be the Mir technically, but
I don't know. It's been so long.
Since you've seen the movie. But the Mir was similar to that, where one time they left for so long, and they came back, and there was like mold growing all inside the Mir, and they had a lot of fires happen, and so the Russian astronauts had probably dealt with a lot of that.
Yeah.
And it's just messing up, and it's overextended use, so they let it burn up in the atmosphere in like 2001.
Yeah, didn't it at one point the fire that broke out was so bad that they couldn't even save it, so they just got all their astronauts off, and then they just let it burn up into the atmosphere.
Yeah, pretty much.
Yeah.
So
hey, it's all about trial and error.
Yeah, exactly. And it's kind of an interesting test to see how long it could stay up there.
Yeah. But yeah, so going, because we're getting, we're kind of bouncing all over the place with the history of space stations, but I think I left off with talking about Alpha.
Alpha Space Station.
Yes. So it used up about 75% of what Freedom had. Okay. So it's not like it was a complete throw out and reset. It used, it reused about 75%, like I said.
Well, that's a lot of money.
And this is the time that Russia decided to jump in on it. So Space Station Alpha had it accepted a couple pieces from some of the Mir space station that Russia had.
Really?
Yes. And it was a way of Russia getting their hands kind of in it. And it was also a way to help lower the cost of the entire program, because now we have 75% of it from what we had for Freedom, but now we still have 25% that we need to worry about. And then Russia's like, don't worry about the 25%. Here's our leftover parts from Mir. Here you go.
So were those leftover parts here on Earth already, and they just launched it up then?
Yeah.
Okay.
Yeah.
That's why I was like, whoa.
Yeah. No, they didn't take it from the Mir that was in the in
with
space.
Mold and burning up.
It was leftover parts from what they had here on Earth that they never launched out.
Interesting.
So we went over the Shuttle Mir. So since the Shuttle Mir program was successful and they were able to dock the Russian technology and the American technology in space, that's when the ISS was born. And since that was successful, then Russia and NASA decided, all right, we're going to launch up Zarya. Russia launched up the Zarya control module, and NASA launched up their Unity node. Right. And they successfully docked and connected. And now you have 2 modules, one Russian and one American, connected together in space. And then I think it was like a month or 2 later that Russia sent up the Zvezda service module. Okay. So now you have 3 total modules connected.
Okay.
The ISS is born. That is how the ISS came to be. And then there was another 32 assembly missions sent since then.
After that.
And it was the year 2000. I think it was like October of 2000 is when the first astronauts began working and living on the ISS. And that was when it was just the 3 modules. And then over the years, I mean, ISS is still in orbit now. So since 2000 up to now, 20 years, there's been 32 additions to it. And now the ISS is big as it is now.
Yeah. The size of a 5-bedroom house. Yeah. The length of a football field. Yeah. And they just signed the treaty again. They're extend. No, I'm sorry. They didn't sign the treaty for ISS again, but it has only like 5 years left or so. Don't quote me on that. On the 5 years left. 5 years left on its treaty, with Russia and like everybody working on it.
Yeah, that's what I
And
hear.
so it could be coming potentially to the end of its road.
It's
they're
possible.
they're trying to figure out what they're going to do with it. They're now with the Trump administration allowing, and they're going to pass more laws on it. So at least there's their plan. They want to make it feasible for commercial companies to put up space stations, and they're thinking about sectioning off part of the ISS and giving it to commercial companies.
Yeah, I
which
heard
is
about
quite a big task because it costs like 1 point something billion to run every year. I mean, I don't know who's up for the task. Maybe Elon, but he probably is just going to put some new space station up, with new technology. That's
I mean, who knows?
not as old, but we've learned so much from the ISS and what we've done, and hopefully we don't just throw it out.
Yes.
Fully.
So you're probably wondering, like, so why did we start talking about working out here on Earth and how it's different in space, and then we went into space station?
Talking
So with me studying systems engineering, there is a small part of systems engineering called human factors engineering that I have recently been very interested in and focusing on in my studies, and that's kind of where like the working out comes in.
Yeah.
So human factors engineering, it's how humans are able to work in a certain environment. So like in space, or you can even say like on Mars or on the moon. And I mean, it gets very specific to like the dimensions of the person's shoulders, their arm length, their reach, like how long their legs are, things like that. That all comes into factor or into play when you are developing space stations, because if you're developing a space station and let's just say like the lab is like super high tech and it's super cool and everything and it works really well, and then you have astronauts go up and they're working in this lab, and then it's time for them to go to sleep and they're too long for their beds. It's not something where you can just be like, oh, just get a bigger bed. No, you can't just do that.
Set it up on the next rocket up, please.
Yeah, exactly.
Order my next bed.
And I mean, it can be tied into anything. Like their equipment that they're using, you want to make sure that it fits in their hand properly, especially when it comes to EVAs, extravehicular activities.
Oh my gosh.
You like, without knowing too much about it or without having much experience, you'd be like, okay, just give them a hammer. If they need to like hammer something, it's part of their tools. But you have to think that they're in huge spacesuits. Like they can't grab a hammer like they can on Earth or in the, without that spacesuit, what they can with their hand and with just their skin. Like they have to take into consideration that it's going to be a different grip.
Yeah.
That's part of human factors engineering. You have to think about stuff like that. And that it just, when it comes to developing space stations, developing, bases on the moon, bases on Mars, and beyond. You have to consider that. You don't want to spend billions of dollars to develop all of these things, and then the astronauts get up there and be like, oh yeah, I don't fit in this.
Yeah.
Like that's not good.
Yeah. Oh my gosh. And I think a lot of people don't even really consider all those details.
Yeah.
And the fact that that's, a big part of systems engineering. That's what you specifically want to work on.
Yes. So systems engineering is like the broad overall thing. But just one of the things that systems engineers has to oversee and has to focus on is also human factors engineering. And just that specific part of the life cycle of that in the development is just, it really intrigues me like more than anything else that I've learned so far.
Yeah.
And I think being able to work on a space station, develop space stations, develop modules, just develop the technology that will help improve astronaut life while they're out in space or out on these other worlds. I want to do that.
Yeah.
That just sounds awesome to me. I would love to go to the ISS.
Yeah.
And just see what it's like to be there. Like that's one of my things on my bucket list is to go out in space, go on an ISS, or if the ISS isn't there by the time I get there, like NASA's developing the Lunar Space Gateway, which is essentially the ISS, but instead of it orbiting the Earth, it orbits the moon. Yeah. That would be awesome if I got a job on there. That would be
There you
sweet.
go. And so the Lunar Gateway, what are we going to be looking more into? Well, we already talked about refueling rockets and other spaceships going to Mars and beyond. But what else are they looking at? And also, Russia, to my knowledge, still hasn't fully agreed or has any treaty in any part in the Lunar Gateway, which is very interesting so far. But a lot more commercial companies, SpaceX and Blue Origins including, have already produced some things for the Lunar Gateway, or they're going to work with the Lunar Gateway, as well as other Boeing and all that.
I'm not exactly sure what Russia's plan is.
Yeah.
I'm not
Who
Russian.
does?
I'm not. We're not in Russia.
Russia.
I mean, we can only just assume.
Yeah.
Maybe they have their own agenda on what they want to do with the moon, or maybe they're building their own gateway, or maybe they've just decided, it's like, you know what, we've spent all of this money helping these guys out into space. We don't want to deal with space anymore, which I highly doubt. I highly doubt that, but it's not a 0% chance.
It's Putin. He's not going to not do that.
But
they need some presence in
so
space.
I'm not really sure what Russia's planning. It is, I agree though, it is interesting that they haven't jumped on board with us.
Yeah, it's kind of curious.
But to be honest, with companies like SpaceX and Blue Origins and Boeing and Northrop Grumman and all of these like private sectors that are coming up to help us out, we don't really need Russia's help.
That's quite a interjection right
now.
There. Hot take.
I could be shoot myself in the foot there, because who knows, maybe Russia has some advanced technology that we don't know about that, like, well, dang it, we could use that. They could make this. But I'm saying, what I'm saying is, we can still accomplish what we're trying to do without them.
Well, if they're in the space station, they just came in like, oh, Alpha Space Station, crap name. And that was a horrible Russian.
That was horrible.
Oh my God. Anyway, but they came in there and helped us out with the ISS quite a bit. So who knows? Maybe they're going to do the same thing. They're going to go do their own thing, and then they're like, what? Let's actually work with them.
That's what I'm guessing. I'm like, if I was a betting man and I had all these options laid on the table, I would say that they are probably trying to figure out how to make their own space station.
To my knowledge, they have a rocket that they want to send and go to the moon, because they haven't put people on the moon. They still want to do
right.
And
they want to go to the moon,
quote.
But do you know if they're trying to make a space station that orbits the moon?
Not to my knowledge.
Yeah, see, I don't know.
So So they definitely don't have a drawn out plan like we do for going back to the moon and going to Mars.
Or maybe they do and they just aren't sharing it with us.
Maybe.
But yeah, so this is exactly what I want to get out of my systems engineering degree.
Yeah, okay.
It is a master's. I'm starting out as a master's. If I enjoy it enough and I get like really into it, I could see myself going and getting my PhD out of it.
That's how you should be. Like, you might go all the way get your PhD and then get into it, and if you hate it, like, you just waste another couple grand on PhD, man.
There's too many people out there that go and this is true for bachelor's, master's, and PhD. They sign up to get their bachelor's and they don't like it. Yeah. Like, they don't know anything about the subject that they signed up for, and they're just like halfway through, they're like, I'm not enjoying this as much as I thought, and they kind of just lose interest. Same thing with, I've met some people that are in PhD programs who are like halfway through, and they're like trying to work on not their thesis, because that's master's, their doctoral. And they're just like, man, I just don't care about what I'm researching anymore. Like, I just don't have the motivation. And I don't want to be one of those people. I don't want to rush into something. Yeah. I don't want to be one of those people who is like, I'm just going to get it, or I'm going to get a PhD because I want a PhD. Like, I don't want to do that. If I am going to pursue a PhD, I want it because I'm thoroughly interested.
But not just that, you're going to try to get the job after your master's.
Yeah.
That is great.
I'm actually going to try to get the job before I finish with my master's.
Oh, okay. There you go.
With internships, co-op programs, and things like that. I think it's very important. And this is like a message to anybody else who's in the middle of getting their degree. Always try to get the job that you want to get into before you graduate.
Yeah.
A lot of employers, they look for that stuff. They want to see that you're interested in getting your job before you even graduate, because that's showing them that, Like, this is 100% what you want to do. You're in the middle of getting your degree, but you want to just get started. You want to, and that's what intern programs are for.
Yeah.
For that exact thing.
I'm going to link you up with somebody I know, and I think he works on the human factors and stuff right now with the SLS stuff.
Really?
Yeah, he's actually agreed to be on the show potentially, so we'll see.
Okay.
But yeah, we're not going to name drop that. But okay, thank you. And dang, that's cool, man.
Yeah.
And I think a lot of people don't realize that this job even exists, and it's one of the biggest ones to really consider, and like how everything works up in outer space. And
so
it's awesome.
The fun way to look at it with what my desires are is I basically want to be like an interior designer, an interior decorator.
Space station interior designer, Dustin McMullen.
4 space stations and 4 bases that are off the Earth. I want to make sure that people are comfortable in their environment, not just. I don't want them to feel like they're in a bunker for the duration of the mission or for years at a time. Kind of like how the ISS is now, where it's all technical. It just there's wires everywhere and things like that. It's just not pleasing to look at. Like you can only be there for so long until it starts to mess with you. You start to miss home. You start to miss like the comfort of everyday things. I want to be able to help design space stations and moon bases and Mars bases or wherever that it leads me to where it makes it comfortable. It makes it feel like home for the person.
That is so important. I think also one thing that people are considering now, I just saw an article on it. They really do believe that they're going to have space hotels. They're even saying as early as 2025. I don't think that's necessarily true. But
4 years from now?
Yeah, that's what I saw an article. They're like, oh, we're definitely going to have space hotels most likely by 2025. I was like, no way. I didn't read the whole article. But interior designing in that aspect is very interesting. Commercial field too, and for space. People aren't even thinking about that. How far you can go.
They might be able to get a space hotel by 2025, but it's going to be like a 0.5 star.
Yeah.
It is not going to be a very fancy hotel. It's basically just going to be like the capsule hotels if you're ever in Japan.
Yep.
It's like the capsule hotels there. That's probably going to be what a space hotel is.
But you get to go up in outer space and be in a hotel in outer space.
I mean, I would definitely sign me up. I'm good to go.
Yeah.
I freaking love the capsule hotels in Japan, man. Those things are awesome.
Have you tried it?
Yeah.
Oh, yeah.
Last year when I went to Japan for 3 weeks.
I didn't know you would. Oh, that's right. You told me about the you told me about that. I totally forgot about you did that. Well, I knew you went to Japan. I totally forgot you actually stayed in one of those hotels.
Yeah. Multiple nights. They were awesome.
That is cool.
For those of you who don't know, a capsule hotel is, think of a bunk bed, but you have a way. It's like a completely enclosed bunk bed to where you just have a twin size mattress. But then when it's enclosed, you have like your own little TV with a remote on it. You can set like your AC or your heat. You have outlets right next to you, so you can plug in your tablet or your phone to charge it and whatnot. And that's your space to stay in. So they're stacked. So like the capsule hotels that I stayed in, it was in Tokyo, so they were actually quite big. And there was a lot of them, but I think it stacked 3 high. So there was one on like the very floor to where you'd actually have to like kind of crouch down to get into it. There was one right about like chest level, and then you had to take a few steps to get on the third one. And I mean, you had probably 10 beds down and 3 high, so 30 people sleeping in just one row of these capsule hotels.
Yeah.
Which I know a lot of people are probably like, oh man, why would you ever like be in that? But it's more comfortable and secluded than you would realize. And the fact, since it's so small and they can fit so many people in such a small space, that it doesn't cost $100 a night like an average hotel does in America.
How much did it cost?
It was like $20.
$20?
Yeah.
Wow, that's so cheap.
It was like $20 a night. And it's like when you're traveling and that stuff, like that's nothing. It was awesome.
I wonder how much the first one would be, or for the first space hotel. Yeah, so Dylan just brought up the article actually that I was looking at. And the California company who I actually heard of through the Von Braun station, which I think about creating. They're actually part of it might be used by the government and NASA. and when it's turning, but other modules might actually be contracted out to space hotels, as they're talking about in other countries and stuff. And so the California company, the Gateway Foundation, has released plans for the Von Braun Station, a cruise ship style hotel floating around the stars. First space station hotel to set to open in 2025. I don't know. That station idea too is crazy.
But it makes sense.
It does.
Tourism is such a huge profit market.
Yeah.
Like every country that has a tourism section is going to make money off of it at some point.
Yeah, that's the exact one they've been talking about, and that is just crazy.
I mean, you know, it's
by 2025 though.
Once
it's going to be so
2025 is pretty optimistic. Yeah. Definitely not going to look like any of those pictures for sure in 2025. Yeah. But as they test it, they do trial and error, they perfect it, they get it more and more luxurious. After they get it on supply chain so that they can build those modules for cheaper, and it becomes fairly affordable for a person, they're 100% going to book that.
100%, yeah.
Like I want to go now. Yeah. How much does it cost?
Yeah. Like, man, look at all this imagine the future right now. We might still have the ISS up there. Other commercial companies are putting their own space stations, testing things. Commercial astronauts that they will be hiring. A commercial hotel.
Yeah.
One of Von Braun Station was this giant spinning station. Then you also got the Lunar Gateway. Space is what they got planned and what they're building and doing. Understand that big idea picture, because it's just all connected for me. I'm like, holy crap. And then we're going to, try to go to Mars. Woo.
That's right.
And you're gonna be at the helm of that.
And systems engineering is gonna get me there.
Yeah.
Hopefully.
Hopefully.
But yeah, that's the dream, man. That's my dream, at least. It's not everyone else's dream.
I think that's
my dream.
That's a great dream, and that's really where it's all going. And I think you would do really well at that, how your managing style is too.
Thank you.
And I'm actually like now getting the whole picture. I was like, that just seems like Dustin. Yeah. So that's really cool.
I definitely like seeing the bigger picture.
I think you're really good with people too. So prices up there for the first space station.
So it says $250,000 per person per trip.
That's still pretty optimistic, I think.
Yeah. I mean, if that's true, is that what's going to be
the
open in 2025?
Aurora Station? There's another station they're talking about. The Aurora Station says to stay 9.5 million.
Well, is that the entire hotel to build, or is that?
Yeah, I don't know.
I doubt that that's per stay. But even if so let's just say that it does open in 2025, and they are able to charge as low as $250,000 per person per stay. They're still going to get people that do it, because they're like, if I had that money, if I was a CEO of a big, multi-billion-dollar company or anything like that, I would definitely pay that money to go and do that. That's like a once-in-a-lifetime thing.
Yeah.
Like, nobody else in the history of humankind before this generation would be able to say that they've done that.
Yeah. Yeah.
That's incredible.
And that is just definitely going to happen. It's definitely going to blow up. So
no, I hope it doesn't blow up.
No.
Please don't wish that upon us.
No, not necessarily that. The Roaring 20s. They see the first space station up in outer space, or space hotel in outer space. The one of Von Braun Station, that is just going to be one massive project. I know the modules are supposed to be, what's that guy's name? The guy that does the expandable modules. Well, they're supposed to be the expandable ones.
You're talking about
what's that guy?
Bigelow.
Yeah, Bigelow expandable modules.
Yeah, the beam.
The beam. Yeah.
Bigelow expendable something modules. I don't remember what the A stands for.
And they're supposed
artificial.
No, I don't know.
Yeah. I don't know. Anyway.
And the station, I know in the middle of it that we just saw in those pictures, that's where it's going to dock whatever spaceship from Earth that's going to dock right in the middle.
Is it supposed to rotate?
It's supposed to rotate to create artificial gravity, and each module is on the outside. So they're going. I mean, this is their plan anyway. They're going to build out, and it's going to spin, and it's going to create the gravity on the really far ends. So I assume if they have to go to the modules, like it's not going to be artificial going to the modules, like in however they transport there to each module. But once they get to the modules, there will be some form of artificial gravity.
Yeah, so the artificial gravity, ever since von Braun made his blueprints, he with space stations to create that artificial gravity, you would have to create centripetal motion. And it has to be at a specific speed so that it would equal approximately 1 g-force, ideally. The faster you go, the more force that you would feel outward, so you would feel more gravitational pull. So, I mean, if you really wanted to, I mean, that could be a great training program in the future if we end up perfecting that technology and we have astronauts go into a planet that has more gravitational pull than the Earth. That would be a great training exercise to have a space station spin at just the right amount of velocity so that they experience that same amount of gravitational pull and then, work and live in that environment for a couple months before you go on that planet. Hey, that's a great idea.
That is a good idea.
But it's so much harder
Yeah.
to actually do than it is to say.
Yeah.
So one of the reasons why we haven't even done it yet, because, I mean, Werner von Braun came up with it decades ago. We haven't done it yet because of how difficult it would be to actually do it.
Yeah.
The reason why it would be so difficult is, so if we're talking about a space station that's orbiting something, orbiting the moon, orbiting Earth, orbiting anything, you have to make sure that the orbital speed stays so that it stays in the correct path of the orbit, as well as spinning to create that artificial gravity. So now you have to worry about two things right there. And as soon as if it gets off by just a little bit, it's going to be so hard to correct it onto the correct path, or to either get it back in the correct orbit or to get it spinning the correct way. Because there's 3 different dimensions that it can spin in. I mean, when astronauts, when they were training for the Mercury program, they were testing out, I can't remember the spins where they completely lose control and they have to try to correct themselves, reorient themselves. I can't remember what the exact terminology of it was, but you know what I'm talking about.
Yeah.
So imagine doing that, but with an entire space station instead of just a little tiny capsule that you're in.
Yeah.
It's so much heavier. There's so much more mass in it. So your momentum is going to be, it's going to be 100,000 times, 1,000,000 times more than a capsule was.
Yeah.
It's just that much harder to make sure that it stays on the correct path. And that's not even talking about trying to dock to the thing.
Yeah. That does the idea of docking to it while it's spinning.
Just imagine. So just imagine that we do end up coming up with a system to where we can make sure that it's correctly oriented. It's in the correct orbit. It's spinning the correct way at the correct speed. Everything's good. Now imagine trying to have something else come to it, match its exact spin, its exact centripetal motion, and to dock at the exact, to get the clamps to attach and everything. That is ridiculously hard.
That's 17,500 miles per hour or more.
Well, as it goes around the Earth,
right,
but with it spinning, it's not going to have to spin that fast.
That's true.
But just think about it. You have to match its orbital speed. You have to match its its rotational speed, and as you're trying to get it to hit, our astronauts had trouble enough as it is when they were completely still in space and they had to correct, in the Y and Z motion. Imagine trying to do that while everything's spinning. It's ridiculous.
It's crazy.
I'm not saying that it's impossible, because it's not impossible. It's just extremely hard, and we haven't built the thruster systems. We don't have the technology advanced enough to be able to perfect it. We can definitely try it now.
Yeah.
And we're going to fail. And it's not going to be good.
I know they in the Gemini program, they did spin they tried to create artificial gravity, and they spun their capsule. The problem is with the force of it, the astronauts were going a different speed than the capsule was. So once they got
So here's the problem. You can't just spin anything to try to get artificial gravity.
Right.
It has to be a donut shape or a toroidal shape, because in the very center, you're not going to feel anything.
Right.
Think of a merry-go-round.
Yeah.
When you are on the outside of that, you are feeling way more force than when you're in the center.
Right.
And it's the same thing with any object in space. It has to be designed to where the astronauts, they can be on any level, but depending on what kind of gravity you want on each level, that's what you have to think of. So when it comes to the Gemini capsule, that thing wasn't circular.
Yeah, no.
So when that's like spinning a rock.
Yeah.
Like the very outside of that is going to be going really fast, and the inside is just going to be kind of sitting there rotating, but you're not going to feel any force.
Yeah.
So of course it didn't work for them in the Gemini capsule.
Why? Dylan's saying he'd be mad if there's gravity on the space hotel. Why, Dylan? That's the whole point of going to space. Well, you're probably going to be able to experience both, like gravity and no gravity, or microgravity.
Well, if we do get to the point where we have perfected the technology to be able to have, space hotels. Well, not space hotels, spacecraft, or whatever, rotating, and we can successfully, dock and undock from it. Then I don't see why we can't have both. We can have one that's spinning, so that you can enjoy a nice meal on a table without it floating up everywhere. And then when especially if you want to take a shower, you're definitely going to need artificial gravity when you want to take a shower.
Yeah.
But then say like, all right, you've taken your shower, you've done it. Now you feel like going and having fun in microgravity. And then you just leave from that space station and go to the other space station or the other hotel. So there. Makes everybody happy.
All right. Do you remember that movie? Is it Passengers with Chris Pratt and Jennifer Lawrence?
I've never seen it.
You never seen it?
No.
There's a scene you gotta watch it because
know.
it talks all about this and like living and they create artificial gravity. And can I spoil one scene for you?
Go for it.
So there's one scene where she is in a pool.
Okay.
And the artificial gravity is like turned off because something happened to the ship. And she started to float and almost starts to drown. Like,
please tell me that the water ended up becoming spherical.
It did.
Okay.
It did. It didn't break off though. Like it was all pretty much sticking together. To my knowledge, I can't. I've only seen it once, so I can't recall the whole scene.
Water does it attaches to itself.
Right.
So that makes sense.
Yeah, I think it. I think it did very well explaining a lot of the sciences. I kind of want you to watch it and give me some of your feedback because that's something you like to do. Is you like to watch certain movies and you're just like, nah, that wouldn't help work.
Passengers has been a movie that I've been wanting to see, and it just. I have Netflix. I haven't seen it on Netflix yet. So I don't have TV and I don't have multiple streaming services. I only have Netflix. So if it's not on Netflix, I probably haven't seen it.
Yeah. We're going to have to watch it. We'll get.
I would love to watch it.
Yeah, you need it.
I was like, I remember seeing Interstellar, and that was an interesting movie.
What do you think?
They got a lot of the theories right when it came to like how time slows down the closer you get to the speed of light. That all made sense. The whole like phasing into the fourth or fifth dimension and like him seeing his past and stuff. That's when I get kind of
that's too
really
theoretical.
Skeptical. Yeah, that's
too theoretical.
When
I know you hate quantum mechanics.
As a physicist, I hate quantum mechanics because it makes no sense. But nobody understands quantum mechanics anyway. Yeah. But when it comes to time traveling and stuff like that, I think that you can travel forward in time.
Yeah.
Actually, you're just slowing your aging down is what it is.
Right.
But you can't travel back in time.
Yeah.
I don't believe that. And all of these theoretical, all these theories with time traveling and all that stuff, when they travel back in time, I'm like, okay, I'm my interest has been lost.
Yeah.
Because that it just from everything that I've researched, from everything that I've read, from everything that I've seen, nothing even says that you can go backwards in time.
I thought you said you did tell me that Back to the Future is like the closest potential.
Yes,
which I was like, wait, what? Back to the Future, really? And I thought that was the most unrealistic one.
I say that it's in my opinion, it's the most accurate one if time traveling to the past was possible.
Okay.
Because I still end up like reading stories and watching movies and TV shows that time travel. And in my mind, I'm like, okay, I'm just going to pretend that traveling back in time is possible. Then there are so many stories that mess up with creating, I can't think of the word for it now. Not loopholes. It's like when you go and you like, let's just in Looper, the movie Looper.
Yeah.
The main character goes into the past, kills himself.
Spoiler.
Yeah, that movie is older than Passengers. So, but the main character goes back in time and kills himself.
Mm-hmm.
It's impossible.
Yeah, that would defeat you.
Because if he kills himself, then he never gets older.
Yeah.
And now, since he's not older, he can never go back in time to kill himself.
Yeah.
What paradox? That is what it's
Paradox
called. Jeez, I couldn't think
yeah.
of this. There's so many stories that just kill it for me.
Yeah.
Even if I pretend that time traveling to the past is possible, they always form a paradox. And it just doesn't work. And I'm like, okay, that now I can't even pretend like it's possible because they just killed it for me. Back to the Future is like one of the only ones that doesn't actually create a paradox. Like the whole premise of that trilogy is to make sure that they don't do it. And they actually succeed. They don't. There's no point in that movie that would create a paradox.
Yeah.
And that's why I like that movie so much, because while pretending that time traveling in the past is possible, they are the closest to making it actually right. If that makes sense.
That is so interesting. And all those movies. Wow. Yeah.
But yeah, I just Looper. Looper with a grain of salt. I was so excited to see that movie, and then when that happened, I was like, "This is the worst movie of all time."
it's almost like when I talk to some veterans or just military people or people that shoot guns, and they watch like all the action films, and they're just like, "Dude, that is just no, you would never do that. Why?" And like they say a lot of pretty much all action films and how they do their scenes and stunts and things and shoot at other people. It wouldn't go down like that.
Mm-hmm. Well, yeah, but
it's very similar with the physics thing, and Hollywood is Hollywood.
I was gonna say, but to defend Hollywood, if they made everything exactly accurate, it would not be very fun to watch.
That's true.
The whole point of Hollywood is to exaggerate reality so that it's really fun to watch.
Yeah, yeah. So. My favorite quote is "Live your life like a movie."
Yeah.
But it's also, you really can't, because there's going to, like a movie, is like an hour, 2 hours, while there's hours in a day, and you have to devote a lot of time to, say, working out and stuff like that. And I know one thing, I'm imagining your life as a movie, Dustin, and you're going to be building space hotels and space stations, hopefully being the interior designer and maybe even going up there. So
I kind of hate that I now said interior designer. I hate that I brought that up.
Every time I see you now, I'm just going to say he's a space interior designer.
Oh, man. I'll just have to own it then.
You just have to
just walk proud and be like, yeah.
You're probably the only one that's ever had that title right now.
I'm sure there's somebody out there,
Possibly.
but nobody that I know.
Yeah.
But yeah. So I appreciate you allowing me to come on in the show, especially because I had to follow Joe Barry, who was on the last episode. And man, I watched that, and he's had some really cool. He's had a cool life.
Yes.
And when you asked me to come on after the episode after him, I'm just like, oh man, I have to be the one to follow that up. Like, really?
Well, I think it was a good transition because he worked with the space shuttle, and then we just talked about with ISS and the space station and like how all that progressed. And I think all everybody that I have on though, man, it's going to be, like I said before, we are trying to get different ideas, different people on to show what people are doing, skill sets, and so many interesting stories and people just in general. Somebody's going to resonate with your story, man, and everybody's story that we have on here. And thank you so much for coming on. I think we will probably, I can go and talk with you for like days on end just about all types of stuff. We'll probably have you on again. Man.
I always feel like we get in some like philosophical conversation whenever we hang out.
Dude, every time he like goes way longer on than I assume. And I feel like we don't hang out as much as we used to. I mean, we used to run away from bears.
One of these days we'll actually tell that story flat out.
We need Dave on here for that, and then it'll just be a recount for that whole thing. And we all have 3 different like perspectives on the story.
I'm pretty sure mine's the most correct, but I'm also biased because that's me.
I actually think yours is the most accurate because I definitely messed part of that story up, and I was like, okay, yeah, he was right. He was right on that part. So I know some parts of where your details and my details line up now, and I'm like, okay, he was right on that.
By the way, I just want to say I am extremely like in awe of this studio that you have made. So the last time that I was in this space, none of this was here. And I remember like the last time we talked, you had the idea of creating a podcast in Huntsville, and I was just like, yeah, that'd be a really cool idea, but like, I hear ideas every single
Right.
day that don't get implemented on.
Right.
And then and then you were like, yeah, I'm actually, gonna set up a studio and everything. I'm actually like, buying the material and stuff. And I'm like, oh, okay. Like he's actually gonna try it out. I'm like, okay, well, I hope it works out for him. Like I'm sure a lot of people who try crazy ideas, most of the time it doesn't work out.
Right.
And then I like saw some of the episodes on like YouTube and Facebook, and I'm like, oh dang, like he's actually like getting the podcast up and running. Like this is cool. And now that I'm in here in person, like this is incredible. I really like this setup and what you and Dylan did with it. So.
Yeah, well, thank you so much, and we hope it just makes sense. All of it just hit. It was really weird how all this worked out, and Dylan hopped on board, and other people have been helping out. And it's crazy.
Yeah,
what's going in. Maybe at the end of the day, at the end of the year, maybe it doesn't work. Maybe something bad happens. That's very pessimistic.
Yeah.
But guess what? We're going to keep trying. We're going to keep throwing stuff at the wall. And thank you for that.
Every system has a life cycle, and every system comes to an end at some point or another.
Yes, life cycles. I just like the idea of life. Oh, man. Well, thank you so much, buddy.
Hey,
it's been good.
Thank you, sir. This has been a fun time. I appreciate it.
Good. Well, you have a good one. Good luck with everything you're doing.
Thank you.
And yes, systems engineering, space stations. Think about the future Rocket City, because that's what we want to promote. And the Roaring 20s is here, and we're going to see some crazy stuff happen. I'm excited.
From Cody. All that crazy stuff is going to be from you.
Yes, it's true. Yeah. Maybe I'll be hosting a podcast on the space station.
Yo, to host a podcast on the space station, I would listen to that.
Yeah.
That would be awesome. Maybe when I get
That's
up
my
there.
biggest goal. All
right, that's gonna be one of my requirements.
The next time you're on.
When I'm making the next space station module, it's going to have a studio for podcast.
Yes. Rocket City podcast, baby. Here we go to outer space.